All right, so time for some examples that use the information from 8.1, including the interior angles theorem for polygons and the exterior angles theorem for polygons. Okay, so we'll start off with a pretty simple one, which is just applying the interior angles theorem. Find the sum of the measures of the interior angles of a convex 24gon. So what we're going to do then is we are going to apply the formula that we had. So we'll have n minus 2 times 180. N again is, in this case, going to, it's always the number of sides. And if it's a 24gon, we know that there are 24 sides. So we're going to have 24 minus 2 times 180. 24 minus 2 is 22. And 22 times 180, calculator comes in handy here, is 3,960 degrees. So that means that all of the angles added up together in that 24gon will add up to 3,960 degrees. One example done. Okay, second one. Each interior angle of a regular n-gon, regular is very important here, and n-gon is only that because we don't know what this number is yet, is 135 degrees. Determine the number of sides in the n-gon. Regular is helpful because it tells us that each angle in the shape is 135 degrees. So, here's the thing. In our formula, we have n minus 2 times 180. And that gives us the total number of degrees altogether within the shape. What that means is, in a regular n-gon, if we take that number and we divide by the number of sides, in other words, if we take this number and divide by n, in a regular polygon, only works for regular ones, that means that we're going to be able to tell how big each angle is, because we know that each of them are the same size. So if we set that equal to 135, we're going to be in business, because we know that each angle in this n-gon has to be 135 degrees. First step to solving this one is to multiply both sides by n. That makes this no longer a fraction, which makes the problem a little simpler. So now we're going to have n minus 2 times 180 equals 135n. We'll distribute the 180 to both of these parts. So that'll give us 180n minus 360 equals 135n. We'll subtract 135n. It's all algebra from here, from both sides. That gives us 45n minus 360 equals 0. You could have done this another way. It might have been a step shorter. Next thing we're going to do is add 360 to both sides. We get 45n equals 360. Divide both by 45. And 360 divided by 45 is 8. So n equals 8, which means that we had an octagon there, because it's an 8-sided shape. So, though that one's a little trickier because, first of all, it's using a changed form of the sum of interior angles theorem, and then you have to kind of work backwards from it to figure out how many sides there are. That one can be a little tough sometimes. Okay, number 3. Each exterior angle of a regular n-gon is 40 degrees. Determine the number of sides in the n-gon. This one's easier. This one is easier because if we know that each of the exterior angles are 40 degrees, and remember, we know that all of the exterior angles will add up to 360 degrees. If each exterior angle is 40 and there are 360 degrees total, we just take our 360 degrees and divide by 40 degrees, and we find out how many angles there are, which is 9. So that problem is pretty short and simple. it's nice that exterior angles add up to 360 makes for shorter problems. They're usually a little bit easier to deal with than the interior angles, and sometimes. Okay. A few more examples. So now we're told that the sum of the interior angles of a regular polygon is 3,240 degrees. What is the measure of each angle? This is going to be like the second one that we did, except now we can just stick to using n minus 2 times 180 equals 3,240. Remember, in that earlier example, we were given that the size of each individual angle. In this one, we're just given the sum, so we don't have to add anything to the formula. It's going to work just as it is. We'll distribute the 180. So we get 180n minus 360 equals 3,240. I'll add 360 to both sides. And that will give us 180n equals 3,600. And we're going to divide both sides by 180. And when we do that, we're going to get n equals 20. So that is a 20-sided shape. Of course, now that we know that it's a 20-sided shape, we are able to figure out how big each angle is. Because now, since we know there are 20 sides, we're just going to take our total angle measure, 3,240, and divide by the number of sides that we have. We couldn't have done this without figuring out the side lengths. And if we do 3,240 divided by 20, we get 162 degrees. Okay, last two examples here. First one, solve for x. Well, in order for us to be able to figure out what x is, we need to know how many degrees are in this whole shape. So to do that, let's count the number of sides. We have 1, 2, 3, 4, 5, 6, 7 sides. So to figure out the total measure of their angles, we're going to use the formula. 7 minus 2 times 180. So we get 5 times 180, which is 900. So 900 is going to be all of these angle measures added up together. So we know that part of the angle measures are this x and this 2x. Those add up to 3x. And then let's add up all the other numbers. So we have 156 plus 133 plus 99 plus 112 plus 145. Those all add up to 645. And those angles altogether add up to 900. So to solve for x, we will subtract 645 from both sides. 900 minus 645 is 255. Then divide by 3 to figure out what x is, and we get 85. Which, if the problem had asked us to, we could have then used to find the other ones. This one over here, you'll see that this shape has all of these exterior angles. So what we're going to do is we are going to, we know that these are all going to add up to 360. So we know that we're going to have 360 equals, and here we have 2x and x. Those will combine to 3x plus, and now kind of like the last one we did, we're going to add up the other parts. So we have 59 plus 59 plus 54 plus 80. That gives us 252. We'll subtract that from both sides. And that gives us 108 equals 3x. Divide by 3. And we get x equals 36. So those are some examples of these problems that relate to this to these properties. So good luck. See you in the quadrilateral stuff.